All right, let's dive in. Today, we're going to pull back the curtain on something that happens inside your computer every single day, but you almost never see it: the file system. You know the feeling, right? You've done it 1,000 times. You finish a document, you edit a photo, you write some code, you hit save, and boom, it's just there. It's safe. But have you ever stopped to think about what magic is happening in that split second? Where is it actually going?
Well, the hero of our story today is something called the file system. Think of it as the master organizer, this digital librarian working 24/7 inside your machine. Its whole job is to manage every single piece of data, acting as this super convenient and efficient bridge between what you want to do and the physical hardware that does it.
Now, to really get how this librarian works, we need to look at its org chart. See, the file system isn't just one big thing. It's actually a really sophisticated system, built in layers, and each layer has a very specific job to do. So, how does this all work? A simple request, like saving a file, doesn't just happen. It actually goes on a journey. It travels from your mouse click down through all these different layers of the system until it finally lands on the physical disk. So let's follow that path step by step. So at the very top, you've got you, and you've got the application you're using. Your word processor, your photo editor, you name it. In our library analogy, you're the patron. You're the one walking up to the librarian's desk and saying, "Hey, can you save this new book for me?" Or "Can you go find that book I was reading yesterday?" Your request immediately goes to the logical file system. Now, this is like the librarian's card catalog. It doesn't hold the books themselves, but it knows absolutely everything about them. It knows every file's name, its size, who's allowed to open it, all that crucial information about the information, the metadata. Right below that, you've got the File Organization module. This is the brilliant head librarian who's memorized the entire library's floor plan. It knows which shelves are full, which shelves have a little bit of empty space, all of it. It takes the request from the card catalog and translates it into a physical location, deciding the exact spot on the shelf where a new file is going to go. The next layer down is the basic file system. Think of this as the library's shift manager. Once the head librarian has picked a spot, this manager issues a simple but specific command. It doesn't go get the book itself, it just tells the staff the exact physical address they need to go to. Now we get to the I/O control layer. This is the hands-on crew. These are the library pages pushing the carts around. They are the device drivers and the interrupt handlers that physically take that command and move the data. They're the ones who actually go to the shelf, pull the book, and bring it to you, or put a new one away. And at the very bottom of this whole stack, we have the devices themselves. This is the physical hardware, your hard disk, or your SSD. In our analogy, these are the actual physical library shelves where the books, your precious data, finally come to rest. Okay, so we've just seen this incredible, layered system that handles all of our requests. But this brings us to the single biggest challenge our digital librarian faces every millisecond of every day: the empty shelf problem. When you want to save a new file, where exactly should it go? I mean, this one decision, how to allocate space for a new file, is everything. It's this constant, delicate balancing act that determines both how efficiently we use our storage space and, just as important, how quickly we can get our files back later. And here's the tricky part. Our librarian is basically trying to do two things at once that often completely contradict each other. First, it needs to use the disk space as effectively as possible. No wasted space. But second, it needs to arrange the files so we can get to them as fast as possible. You see the problem, right? Packing things in super tight to save space might make them really slow to retrieve later on, and spreading them out for speed might waste a ton of space. So how on earth can the digital librarian do both at the same time? Well, it turns out it has a few different strategies or allocation methods it can use. Let's start with the most straightforward plan, the one that probably seems like the most logical way to do it at first glance. It's called contiguous allocation. The logic here is just beautifully simple. When you save a file, the system looks for one single continuous chunk of empty space on the disk that's big enough for the whole thing. It puts the file there, side by side, and all it has to remember is where the file starts and how long it is. It's just like putting all the volumes of an encyclopedia set right next to each other on one long shelf. But this beautiful simplicity creates a huge trade-off. On the one hand, this method is incredibly fast for reading files, since the disk head doesn't have to jump all over the place. But the downsides? They are severe. It creates all these tiny, wasted gaps of space, a problem called fragmentation. And this is the real killer. It's almost impossible to make a file bigger once you've saved it.
And this right here is the central flaw. If your file is wedged between two other files on the disk, there's literally nowhere for it to grow. The system would just have to tell you, sorry, this file cannot be expanded. Your only option would be to move the entire file somewhere else, which is a massive headache for the system.
So if the simplest, neatest, most obvious plan of putting everything side by side has such a fatal flaw, it really begs the question, what clever tricks do our computer's digital librarians use instead? How do they manage to store our files efficiently and still let them grow and change on the fly? That, my friends, is where the real genius of the file system truly begins.